Shut your mouth. Here we go. Okay, we're talking about gas properties.
No, renting it and buying. How are the rules?
Or is it you to tell you where the parts?
Be quiet, please. Gases are compressible. They have indefinite volume. Indefinite shape. What does indefinite mean?
Means no defining.
Means not defined or not fixed. Okay? They take up whatever volume of the container. Also, they take the shape of the container. They're in constant motion. Okay, solubility decreases as temperature increases. What does solubility mean?
Like break something. I can't.
What does dissolve mean?
That's break down. I don't know.
To
Dissolving, you dissolve a solute into a solution, right?
Yeah.
So solubility is how well something dissolves. So as you increase the temperature, the solubility of a gas decreases. What does agitation mean? Shaking it up, stirring it up, mixing it. Okay. So as you shake up something, the solubility of the gas inside of it decreases. That's why Cokes spew when you shake them up. Because the solubility of the carbon dioxide in the Coke decreases as you agitate it, shake it up. Also, that's why hot drinks tend to release the gas faster than cold ones. But most of this stuff you probably already knew, right? There are three ways or properties, or however you want to say it, of gases that we measure. What's one of them? What are properties of gas that we can measure? Volume.
density.
Okay. We'll go with volume first. How do we measure volume?
Don't you have to do like a triangle thingy and then?
No, I mean, like, what units do we use?
Centimeters.
Milliliters.
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 We also use liters. How many milliliters are there in a liter?
10. Or just guess.
1,000.
1,000.
One cubic centimeter is equal to 1 milliliter, like athletes say. We don't use that one a whole lot, but you may see it some. Has anybody ever heard of a unit of measure called a cc?
Yeah.
What does CC stand for? Cubic centimeter. So it's the same as milliliters. You usually hear it in the medical field. That's just a different way of saying milliliters.
Yeah, and the way they say it too always makes the patient freak out.
Sometimes. All right. What's another way we measure, or what's another property of gases we measure?
Density.
Not really.
Mass.
No.
Height.
What are we talking about?
Properties of gases that we measure. What's unique to gases?
Oh, smell. No.
What about pressure?
Pressure.
Side effects.
We have several units of pressure. We have atmospheres. Which is abbreviated ATM. We have kilopascals.
Isn't it healthy to smell your own fart?
According to some people. We have millimeters of mercury, which is abbreviated mmHg. We also have torr, which is abbreviated torr. One atmosphere is equal to 760 mmHg. It's also equal to 101.325 kilopascals. Also, 1 mmHg is equal to 1 torr. They're the same thing. You get this is equal to that is equal to that, right? I can have to remember to write it all out. What units do we use to measure temperature with gases?
Fahrenheit. Celsius. I don't know.
Not Fahrenheit, not Celsius.
Is that the Kelvin
It
deal?
is Kelvin.
Kelvin Clyde.
Anybody know why we use Kelvin?
Because it's like the most pure
No.
representation.
No.
Because it can reach absolute cold.
Well, you're on the right track. It's because there are no negative numbers. Kelvin. 0 Kelvin's the coldest you can get. So that helps in our calculations where we don't have negatives.
I wonder if we could actually see 0 Kelvin.
You'd be dead. To convert Celsius to Kelvin, take your degrees Celsius plus 273, and you get Kelvin. You notice I didn't put the degree sign on Kelvin, because Kelvin's not in degrees.
It's just a number.
It's just a number. It's just
Wait,
500 Kelvin. It's not 500
does
degrees
the C
Kelvin.
mean?
What's that?
The C mean?
Celsius. You don't say degrees Kelvin, you just say Kelvin. Okay? You write it Kelvin, you want the degree sign. Questions so far? A lot of the stuff you've already had in the past. Okay. Kind of raise the pressure stuff too.
Mm-hmm.
Basically.
All right, there's a set of values that are special in chemistry and physics, for that matter. It's called standard temperature and pressure. Can anybody tell me what the value for standard temperature is? Anybody have a guess?
Like number?
Like value, yeah.
0.
6.
7.
It's 0 Celsius, which is 273 Kelvin. Anybody know what the standard pressure is?
0, 273. Oh wait, that's
That's temperature.
500.
500 what?
Pound pressure.
That's not a unit we use. It's a volume. It's not a pressure.
Atmosphere.
One
Pounds.
atmosphere.
One atmosphere.
Standard pressure is 1 atmosphere. Or 760 mmHg. Or 760 torr. Or 101,325 kilopascals. Those are all the same pressure, just different units.
So however many mmHg and equals torr, basically.
Yeah, basically. But they're basically the same unit, just labeled differently, because they're equal to each other. A lot of times, standard temperature and pressure is abbreviated STP. So you'll see that some. You need to have that memorized,
STP.
what those values are. And honestly, if you can remember 273 and 1 ATM, you can convert the rest of these by the conversions I give you. So those two are the main. Remember. Questions so far? All right. We're going to get to our first gas law today, called Boyles Law. Boyle's law states that pressure and volume are inversely proportional. What does the word inversely mean?
opposite.
It's more complex than that, but that's the basics. It's opposite. So if the pressure goes up, what happens to the volume?
It goes down.
It goes down. That's what it means to be inversely proportional.
Boom.
Okay, and it goes down by the same amount. So if I have a balloon, okay, of a certain size, I will do a lot with balloons in this unit. I'll bring some long ones. I can make you some dogs and stuff out of them.
Will you let some go?
What?
So will you let some go?
I'll bring my helium tank. We can.
Yeah.
Get
All right.
on helium.
So you've got a balloon. It has a certain volume, right? And the pressure is about 1 ATM. Okay? The pressure on the inside is the same as pressure on the outside, right? The atmospheric pressure here is, it's a little less than 1 ATM, but it's about that. Okay? Because you average 1 ATM at sea level, and we're above sea level, so it'd be a little bit less. But we'll say it's 1 ATM just to be fun. pressure's 1 ATM, and it's probably about 1 liter in size, or maybe a little less. If I decrease this, if I squeeze it, apply more pressure. If I increase the pressure to 2 ATM, what's the volume going to do? The volume's going to change. The volume's going to decrease, isn't it? So if the pressure is 1 ATM, starts out at 1 ATM, and you have 1 liter, and I put 2 ATMs on it, what's the pressure, the volume going to be? Be half a liter,
Half a liter.
because it goes down by the same amount, same proportion. Make sense? Because my volume, if I squeeze it, apply more pressure, it decreases, doesn't it? I let it off, it goes back to where it was. Okay? Everybody understand that? Okay. So the formula we use is P1 V1 equals to P2 times V2. You get that you multiply here, right? What's the ones and the twos mean?
Volume 1, volume 2.
So like the starting and the ending?
Yeah.
So you have like the starting and the ending, the beginning or the last or whatever you want to talk, final, whatever you want to talk about.
I thought I was right, bro.
Okay. So you have the starting and the end, two different ones. Okay. You have to keep them together. Now, does it matter? We have all these different ways to measure volume. I mean, not volume, pressure. Does it matter what I use?
Yes.
Sort of. Yes and no. As long as my pressure over here is in the same unit as my pressure over here, it's fine. Okay? Same with volume. If I have liters on this side, I'll need to have liters on this side. Or milliliters and milliliters. You should have to be consistent. Okay? There's only going to be one formula we're going to have in this unit that it matters. And I'll let you know when we get there. Okay? Otherwise, it just has to be the same as you go across. Okay? Does that make sense? So it's very important that you label what you have. Okay? Keep your units all straight. Any questions? All right. We have an assignment using this formula. I'm going to go through the first one with you. Work out together. Then we'll go from there. All right?
Still recording.
I know. I'm going to record myself going over this first one.
Oh, okay. You posting this?
Yeah.
Give me that back.
Where's my hands?
Why are you an idiot?
Yeah, like this, I was paying attention later.
Again.
Why are you an idiot? Joey.
You doesn't know. Okay. So a gas occupies 12.3 liters at a pressure of 40 mmHg. What's the volume when the pressure is increased to 60 mmHg? So what is P1?
Well, I did 12.3.
P1. Which one's the pressure there?
Oh, 40.
40. P1 is 40. What's V1?
12.3.
12.3. Liters or milliliters?
Liters.
Liters. What's P2?
60.
60. And thank goodness our units are the same on both sides for pressure. Otherwise you have to convert. And V1, or excuse me, V2 is our X, isn't it? It's our unknown. Okay, 'cause it's asking
Oh, this kind of looks easy.
about the volume. So far, I mean, in the beginning it is.
Yeah.
The hardest part about this unit is going to be which formula do I use where when we get them all mixed up together. But we're going to take it step by step. We're going to go through all the formulas and we'll put them all together. All right, so 40 times 12.3 equals 60 times V2. So we multiply this, right?
492.
40 times 12.3, 492, correct? Divide by 60. 8.2, correct? And it's gonna be liters. Make sure you have your units. No units means it's wrong. Confusion?
No?
We pretty good on that? No, it's not. You got plenty of time right now to work on it. Turn it in tomorrow at the beginning of class.